Okay, what's up, everybody? These are summations. I'll show you a few little tricks on the calculator and things like that. Again, I'm not like a master of summations. I understand what they are and how to use a calculator somewhat. I'm sure there's an easier way of doing it, and if you have a more advanced calculator or whatever, there's probably a different way. But I'll just show you the way that I understand it, and I'll show you the longhand method. So, like when you forget everything in the universe, you can do this method, and it'll be all good for you. Okay, so this is a summation. Again, what a summation, just basically, before we get to these problems, is this. This is a Greek letter. This is a Greek letter sigma. Sigma. And what sigma does is it adds things up. So what they'll do is they'll introduce some sort of variable, like n or something like that. Actually, let's make it a different variable. I apologize. Um, let's make it like, as they use here a lot, I. They'll introduce a variable I, and they'll say I will start at the number 3 or something like that. They'll start you off at an integer. And then they'll say, give you some sort of n up here, and this is, they won't say it, but this is usually the letter n, and they'll give you some stopping point, like the number 5 or something like that. Okay, and so what this means is this. Right here, they will usually give you some sort of equation, like, 2i or something like that. Or let's make it a little bit more complicated. 2i plus 1. Okay? And they'll give you some sort of equation. So ultimately, what you're going to be doing here is you're going to do this entire equation with the number 3. And then you're going to do this entire equation with the number 4. And then you're going to do this entire equation with the number 5. And this continues on until you hit that top end point. So here we would stop with the number 5. So ultimately what this would be is 2 times 3 plus 1. And then what a sigma is a summation, which means sum. You add them up. So it'd be this plus 4 plus 5. And again, this continues on and on and on until you hit the last mark. And here we set the last mark at 5. So this would be what? 7 plus 9 plus 11. So this would be 27. And then again, I'll kind of show you how to use your calculator to kind of help you out with this. Again, I'm not a master at the calculator, but I do know how to do this a little bit. Okay, so what I'm going to do is I'm going to write this the longhand. So you see that this is going to begin at the number 1, and it's going to progress to the number 6. So that would be 3, 1 plus 2. Then it would be 3, 2 plus 2. Then it'd be 3, 3 plus 2. And then it'd be, what, 3, 4 plus 2. Let me give myself a little bit more room here. Then writing with this marker is like writing with a big old crayon. All right, plus 3, 5 plus 2. Plus 3, 6 plus 2. And that would be it, because that is that top number. So that's where this summation would technically stop right there. So this is our summation. And so if it's simple enough and easy enough like this, it's all good, and you can pretty much use your calculator to get what you want. So this first number is what, 5, and then plus 8, plus 11. Plus 14, plus 17, plus 17 plus 20. So this ultimately should come out to be the answer 75, unless I missed one. So again, yeah, so this would be 5, 6, 7, 8, 9, 11, 12, or excuse me, 9, 10, 11, 12 to 14, 15 to 17, 18 to 20. So 5 plus 8 plus 11 plus 14 plus 17. Okay, yeah, so that should be correct. Right, now, how to use the calculator. There's a lot of stuff, and there's not a whole lot of questions that are going to be asked, but here's how I do it anyways. What I first do is I go to the Stat button on my calculator, and then I go to Edit. So I go Stat on the calculator. It's right kind of by the arrow buttons. And then the first option in there is Edit. And this brings up some lists. So if there is crap in the list, if there's like numbers in the list, what you want to do is you want to go up and highlight the list itself, like I have up on my calculator, and then hit clear. And then arrow back down. So I hit clear and then arrow back down. So if there's junk in here, all right, what you do is you go up, you highlight the top, you hit clear, and then you arrow back down. Okay, and that will clear your list. Okay, then what I do is I go and I enter the numbers starting with the smallest number that you need to start with and go to the biggest number that you want to go to. So here I would go like 1, enter, 2, enter, all the way up to 6. So I go 1, 2, 3, 4, 5, 6. So I start at the smallest number that I'm going to, and I go to the biggest number that I'm going to. Okay. Now, notice that I am putting this in list 1, or AKA L1. Okay, we'll get to that in a moment. Okay, so what I want to do is I want to get out of here and I want to actually do the summation. Right? I want to actually do the summation. So what I want to do is get out of the screen. So don't hit clear or anything. What you want to hit to get out of here is you want to hit second, and then you hit the mode button, which is quit. So you hit second and then the mode button right next to it, which is quit. And that goes back to the main calculator screen. All right. Now, last but not least, how do I actually get to the summation? Where it gets pretty crazy. I'm sure it's in here somewhere, like maybe under the stats. I don't know if it is. Maybe not. Maybe math. Again, I've yet to find it. I don't know. It's in here somewhere. Where I know where to find it is under the catalog. So if you look at the very bottom of the catalog, under on top of the 0 button, there's the word catalog. So to get to that, you have to hit the second button again. You hit the 0 button, which is the catalog. So I go second catalog. This brings up everything. I want to jump to the word sum, which is the letter S, but to get closer, what I do is I hit the 4 button, which is technically the letter T, and then I go up 1. And that brings in the word sum. All right, so that brings in the word sum. All right, now it's pretty easy. All you have to do is enter the equation that you're using. So sum is this right here. It's that symbol right there. And we've set up the calculator with our list to go from 1 to 6. That's what it's going to do. Okay, so that's what we were ready to rock and roll for. And then so all I have to do is enter the equation that I need. So here it's going to be 3i, but I'm going to enter that as list 1. Again, how I do that is list 1 is written above the number 1, so I have to hit the second 1, which is list 1, to get that in there, and then plus 2. So this is going to be 3i, so I go shift, or excuse me, second list 1 plus 2. And that does your summation. You screenshot this or something. I'm going to have to erase this here in just a second. So ultimately, this next question, question 3. Again, I would go to my stat, edit, clear out that list. Here, this goes from 0 to 4. So I put that in. I quit out of here. I'm going to sum 1 divided by the quantity of list 1 squared plus 1. And so this is ultimately going to be 158 over 85. Like ultimately. Like the cheating version. All right, so let's go ahead and how I would do that. Like again, I know how to use my calculator. If you need to see this stuff, just rewind the video a little bit. So here's really how I would kind of do it. I write it out the long version. So I have 0 squared plus 1. I have 1 squared plus 1. I have 2 squared plus 1. 3 squared plus 1, and 4 squared plus 1. So this is 1 plus 1/2 plus 1/5 plus 1/10 plus 1/17. That's what this is. There it is. Again, what I would do to use the calculator, if you can just straight up use the calculator, is I edit, I set up this list to go, in this case, from 0 to 4, 0, 1, 2, 3, 4. All right, and I put this, again, be careful when you make this thing, make sure your numerator is completely separate than your denominator. So this is in essence what I'm summing. I'm taking the catalog t up 1 sum, okay, of 1 divided by list 1 squared plus 1. Close that denominator, close the summation. Okay, fraction, math enter, enter. There it is. Really, there isn't usually too many summation questions when it comes to the Big Show, but I do know that on the test there is some, but it's more like kind of like problem number 1 kind of question up there. These are trying to teach you how to do integrals. Right, so here, this is a constant. So again, for every k, we're going to be putting in this number. Now, notice that there isn't any k's. So what this would be is, for when k is equal to 1, I put it in for every k, so that would just leave c. Plus, when k is equal to 2, I put it in for every k. Again, there isn't still a c. K is equal to 3, and then k is equal to 4. But notice that there isn't any k's, so that doesn't really go in there. However, the iteration, the summation still goes again and again and again and again and again. So ultimately, we have c plus c plus c plus c for when k was 1, 2, 3, and 4. So this is ultimately going to be 4c. That'd be like saying in my calculator, if I go from 1 to 4, and I'm just going to take the summation of, some constant, like the number 6, right? And so what this will do is this will iterate 4 times. Actually, no, it won't. It won't. It won't understand this. Never mind. It doesn't know to go 4 times. So you foiled my process. But yeah. Anyways, but yeah, this is what it is. So the calculator isn't a perfect tool. You have to kind of know how to outsmart the calculator a little bit. Okay, here they just want you to use sigma notation. So I see that this starts at, excuse me, getting ahead of myself. This starts at 1 and goes to 11. That's kind of the thing that keeps changing and changing and changing. So that means our summation is going to start at 1 and go to 11. And then in essence, what I do is I just write this exact same equation, but wherever the changing number is now the letter I. So this is going to be 5I as such. Hooray. They don't ask you to actually do the problem. They just want you to write the equation. All right, so here, the number that is changing is this numerator. So I see that it starts at 1 and it goes to 6. And this is going to be 7I divided by 6 plus 5. Okay, I don't think they asked you to answer this question. I may have on my answer key, but they say write this as a definite integral. All right, so this is on the interval from 1 to 5. So here we go. This is an integral. An integral is like a giant S-looking shape. It's like a giant S-looking shape. Okay, the lower bound is -1. That is written at the bottom. The upper bound is +5. That's written as the top. And then the variable that keeps changing is the c. That's going to be our x. So this is going to be 3x plus 10. And then this is the symbol delta. This is a change in. And so what we write it as a d. D is the same thing as delta, so a change in x. And there, we just wrote our first definite integral. The difference between a definite and an indefinite integral. A definite integral has numbers here. An indefinite integral doesn't. And we'll talk about the differences, but the big note difference is an indefinite integral is going to get these plus c's. It's the same thing as an antiderivative. If you're doing a definite integral, you don't get these plus c's. You don't get this plus c. And we'll talk about, again, what you do in both of these situations, but that's the keynote difference. Definite integrals, you're going to get answers to stuff. All right, so again, here we are going from 0 to 3 of x squared plus 4 square rooted dx. Here, integral from 1 to 5 of 1 plus 3 over x dx. Okay, so what these things are doing, what a definite integral does is this. I know I explained it a few times, is this. Say I want from like 1 to 3 of, x minus 4 or something like that. All right, and so what an x minus 4 looks like is a line like such. Close. Okay. Looks like a line. And so what this will do is this is the area from 1 to 3. So what is this area from 1 to 3? And so I see that this is a trapezoid underneath the curve. So this has a height of 2 and a base 1 of what? 3 and 1. So this has an area of 4, but it's underneath the curve, so this would be -4. So again, all this thing is the area underneath the curve. This was kind of a bad example because it's underneath, but you get the idea. It's the area to the x-axis. That's what one of these things is. So here, in this problem, they want you to write this as an integral. Don't answer it, but write it. So here's the area. All right? So they want us to write an integral. So we see that the area starts at 0 and goes to 4. It starts at 0 and goes to 4. And then what is this equation right here? This is y is equal to 5, so it's just 5 dx. In essence, they give you the y. So here, the area starts at -4 and goes to +4. So this is going to be from -4 to 4 of this. And again, that will get you this area. So we are going in this case from -5 to +5 of 25 minus x squared dx. And then last but not least, this area goes from 0 to pi over 2 of cosine x. Oh, more. Ooh, this one's weird. This one goes to the y. And so, but notice how everything is written in y. So all the x's are now y's. So, including the interval. So this one goes from 0 to 2 in the y of y to the third dy. That one's kind of weird. We'll talk about that in an upcoming chapter. So you can integrate that one. Okay. Again, this one goes back down to the x, and that's the interval if you can't quite see it. And so this one goes from 1 to 4 of 2 over x dx. Okay, then they want us to do this integral, but using geometric formulas. So, okay, so the graph of 4, they say graphic. So graph of 4 means this. 1, 2, 3, 4. Here's our graph. And they want this evaluated from 0 to 3. So this is the area that they are concerned with right here. What is that area? Well, that is a rectangle. So this area has a base of 3 and a height of 4. This answer is going to be 12. Okay. This has a graph of x. So up 1 over 1 kind of idea. So this is on the interval from 0 to 4. So at 4, this is going to have a height of 4. And so what they want is, what is the area underneath this curve from 0 to 4? So they want to know what is this area right here. That is a triangle. So that's 1/2. The base is 4, and the height is 4. Okay, here they have the equation 3x plus 4. So this will have a y-intercept of 4. So I'll count in twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not exactly sure where this is going. And this is going to go 1, 2. 2, 4, 6, 8, 10, 12. This will get up to 10. Okay, so what this does is this starts at 4, and it goes up to 10, and this is a line. Back. Okay, that's what the picture is. So from 0 to 2. Okay, and they want to know what is this area from 0 to 2, and they want to know what is this area right here. This is a rhombus. This is a rhombus. So again, excuse me, a trapezoid. I'm sorry, a trapezoid. So this is 1/2. The height, again, think of it sideways. It has a height of 2, and the parallel sides have heights of 4 and 10. So 1/2 height, base 1 plus base 2. So 1 minus square root of x. So this has a y-intercept of 1. This has a y-intercept of positive 1. And it's an upside down absolute value. Okay, so that has slopes. So this would be positive 1. This is negative 1. And they want to know what is the area from negative 1 to positive 1. This is area right here. So this is going to be a triangle. 1/2, the base has a length of 2 and a height of 1. All right, this is a half circle with a radius of 7. Okay, I've done enough problems that I recognize what I recognize. Again, what an equation of a circle is x squared plus y squared is equal to r squared. So what is happening here is they did this. They subtracted x squared, and then they square rooted. Now, technically, it could be a full circle. It would be plus minus. Okay, so what is missing is the minus. So this would be a graph of a full circle. Okay, but with the minus part gone, you don't get the bottom part of the circle. And then if this number is straight up 49, that means r would be 7. So this is a half circle with a radius of 7. It's the upper part of the circle with a radius of 7. Okay. I think this question, or a question like this, is on the test, so be conscientious about recognizing the equations of a half circle. All right, so this is a circle with a radius of 7. 8. This is negative 8, positive 8. So 7 will be here. All right, so this is negative 7. This is positive 7. This is 7 right here. This is a half circle, and they want to know what is the area of this half circle. And so that area would be 1/2 pi r squared. Okay, pi r squared is the area of the circle, so this is 1/2 pi r squared. And so cleaning this up, this would be what, 49 over 2 pi. That's it.